we're going to talk about the notable lines and points of a triangle. A notable line is simply a segment that is in a triangle and has very important properties. When the notable line intersects, they form what is called a notable point, which also has important properties. Let's start by drawing any triangle. It obviously has 3 points, 3 vertices. When they are joined, they form 3 sides, and among them, 3 angles. The number 3 is very important. There are 3 of each notable line. Let's start with the angle bisector. The intersection of the angle bisector will form what is called the incenter. Remember that each set of notable lines generates a notable point. What is the angle bisector? It is simply a segment that divides each angle into 2 equal parts. We draw the bisectors. Notice that each angle was divided into 2 equal parts and a point called the incenter was formed. Now, what is the incenter for? An incenter is the point for which a circle is inscribed inside the triangle. But what will be the radius of that circle? The radius goes along the bisector and starts from the incenter to the corresponding side. Obviously, the circle will touch all sides without leaving and will be perfectly inscribed in the triangle. Now let's look at another notable line called the median. There are 3 medians. When they intersect, they form a notable point called the centroid or Bisector. A median is very easy to draw. It is simply a segment that goes from the vertex to the midpoint of each side. Let's do it. The first step is to locate the midpoint of each side. Now, we connect each vertex with the midpoint opposite to it. The point with the 3 medians intersect is called the Bisector or centroid. We can also call it the center of gravity. What is the centroid used for? The centroid determines a point in space that divides each median into 2 segments. This green line of the median is twice as long as the other part, which is red. Let's look at another median. The longer line, the green one, will always measure twice as much as the shorter line, the red one. Another important property is that if I want to balance a triangle on the tip of a pencil, I must place it exactly on its centroid. That is why it is also called the center of gravity. Now let's move on to a notable line called the perpendicular bisector. Obviously, there are 3 perpendicular bisectors that intersect and form what is called the circumcenter. A perpendicular bisector is simply a line perpendicular to each side that is drawn from the midpoint of each side. Let's do it step by step. Let's draw the midpoint of each side. From this midpoint, I will draw a perpendicular line. It forms a 90-degree angle with the side it is on. I do the same with the 3 points. It is not necessary for the perpendicular bisector to intersect the vertices. This line didn't pass to point 8. This line is far from point B. This line was close to point C but didn't touch it. Now, the point where the 3 perpendicular bisectors intersect is called the circumcenter. You should know that the circumcenter is not always located inside the triangle. It can occur outside the triangle and it is perfectly valid. The circumcenter is the point that will be the center of the circle that circumscribes the triangle. The radius of the circle goes from the circumcenter to any of the vertices. I draw the circle and you can see that the triangle is inside. But let's clarify the difference between inscribed and circumscribed. Remember that inscribed means that it's inside. So with the incenter I create a circle that is inscribed inside the triangle. Now, circumscribed means that it surrounds. The circle will be outside. In this case, it is said that the circle circumscribes the triangle. And it can be said that the triangle is inscribed in the circle because it is obviously inside. Let's look at another notable line called the altitude. Every triangle has 3 altitudes. The altitudes intersect at a point called the orthocenter. An altitude is simply a perpendicular line to each side that is drawn from each vertex. From each vertex, we project to a 90-degree angle towards the opposite side. We have 3 altitudes that generate a point called the orthocenter. What is the orthocenter used for? With these points, several things can be done. Let's see. I can take these 3 points and connect them. This new triangle is called the orthic triangle. The 2 triangles are similar, the small one and the large one. The orthocenter also allows drawing a circle inscribed within that orthic triangle. In this case, the orthocenter becomes the incenter of the small triangle. Now, let's talk about another notable line. Let's talk about Euler's line. This line passes through 3 points: orthocenter, bericenter or centroid, and circumcenter. Let's draw the triangle. Let's draw the orthocenter. The orthocenter is obviously the one formed by intersection of the altitudes. We'll color it green. That's the orthocenter. Now, let's draw the centroid. Remember, it is formed by the medians, the lines that go from the vertex to the midpoint of the opposite side. We'll color it fuchsia. Finally, we draw the circumcenter. Remember, from each midpoint a perpendicular line is drawn. We mark that point in blue. I have 3 points: orthocenter, bericenter or centroid, and circumcenter. We draw Euler's line. These 3 points should be perfectly aligned, and these conditions must also be met. It is always true that the centroid is located between the orthocenter and the circumcenter, and the distance between the centroid and the orthocenter is exactly twice the distance between the circumcenter and the centroid. And okay, we're done.